Here's one way to set up some custom hypotheses. So suppose I have this data set, and in this data set I've got a completely randomized design, but with two factors. One factor has 4 levels and the other factor has 3 levels. And I'm supposing that the one with 4 levels, I'm calling it factor 2, is just purely categorical. So it's like A, B, C, D. Maybe A is some kind of control, and the other 3 are 3 different ones that I might compare to each other. And then factor 2 might be linear, so maybe this is different levels of a drug, say 0.5, 1, and 1.5. For the things that I'm doing, you'll want them to be evenly spaced here. And then I created this data set, just you can see how I randomly created it. And then I created a new variable treatment that has 12 levels, one for each of the treatments. So if you have factor 1 of this level and factor 2 of that level, then the treatment is that level, and so on and so forth. So I'm just showing you how to set it up, kind of. And then if you want to make contrasts and comparisons within each of the individual factors, say you want to look for a linear trend across the levels of factor 1 and a quadratic trend across the levels of factor 1. You can do that way, or if you want to compare and contrast, A to the control, that's how you would do it. Or if you want to contrast B and C, that's how you would do it. You want to be careful that these numbers should always add up to 0. And if you want like orthogonal contrasts, then if we add up -1 times 1 plus 0 times -2 plus 1 times 1, that should be equal to 0 to get orthogonal contrast. And then I'm going to use contrast and estimate for all of the contrasts that I create, and you can see how that turns out very nicely. These are the actual estimates, L times beta hat, where L is your vector, your contrast. And then the contrast statement just gives you the sums of squares. Then if you want to go through different kinds of contrasts for the interactions, this is how you might do that. I've got one set up here. This is going to be an interaction. You may want to set things up this way, especially when you have a missing treatment, but you still have a crossed factorial structure. This may be a good way to get all of these contrasts. One more thing that you want to pay attention to is the fact that I'm using a comma here for these two treatments. This is another way of doing this. Here it changes the degrees of freedom. See how I'm going to run these two contrasts together with this comma. It's not two separate contrasts. And same thing with these 3. So we're going to get slightly different results than we got up above.